Welcome to a new Syvecs help video. This help video is based on the new Syvecs software and the new Syvecs custom renaming and custom configurable maps firmware for the S6, S8 and S12 based ECUs. As you can see in front of us, we've got the two downloaded exe files from the forum of the new S6 firmware and S12 firmware. What we're going to go over today is actually the S6 firmware, the version 1.64, and we've actually got an ECU here on the test bed that we're going to go over it and explain how it works. So first thing we're going to do is we're actually going to run the firmware file on the ECU. So we're going to make sure that first of all the calibration is saved, and then we're going to actually run the exe file. So we're going to run the exe file. It's going to find the ECU, and you can see here where it says found S61402. Now this is the firmware version of the ECU. This is the actual serial number of the ECU. What we need to do here is actually request you to enter the serial number. So just put in 1402, press enter, and we can actually see that it's erasing the code that was on there. This will completely wipe the calibration which is on the ECU, so it's important to have a backup of it before. Okay, once you've done that, then going to open SCAL and then go Device, Connect. It will find the ECU, and at the moment there's no calibration loaded in the ECU. So what we're going to actually do is run through how to now update an existing calibration on an earlier firmware version like 1.57 to the latest 1.64. So I go back to my Explorer window. You'll see that I've got a base map here for a R35, which is running on the 1.57 firmware. Now what I'm going to do first is go to Cal and then change software version. Once I'm in here, choose the latest S6 firmware revision, which is the 1.64, enter, and what it will do now is it will successfully tell you which maps have imported and which maps have not imported. The important thing to do here is to actually use the tag function. The tag function basically then marks all of the calibrations that have changed on the ECU and part of the calibration to ensure that basically you're aware of any new maps or anything that could basically change the way that the car runs. The most important thing that we need to look at is the I/O configuration. You'll see in the pin assignments here, as you scroll down now, and you can scroll down faster by using the page down, you'll see there's a few undefined items. These are new items which have been added into the calibration for new features of the ECU. So the pitch and roll is to be used with the new GPS unit, the 50 Hz unit, which we're about to release. So what we need to do, if we're not using those, we need to set them as not connected. Otherwise the ECU won't actually allow you to come online. So we'll set these all to not connected. There's a few extra inputs down here for engine oil level and stuff like that, and what you'll notice is these inputs are now at the bottom actually segregated into their own sense definitions which start with U. Now the important reason for this is that these actual sensors can now be renamed. Okay, so these are user definable sensor inputs. These are sensor inputs that are not used by any strategy that's important that can potentially damage anything if we start changing it. Okay, so what we have to do is we have to unassign these, and then we'll go back over these afterwards and talk about how you can rename these and use these. So again, we're going to go down. We found there's loads more fan outputs now. Now these fan outputs can be renamed and basically changed to whatever is required. I'll go over that a bit more later, but for the time being, we'll just set them as not connected. Once you've done that, you need to go to the next section, which is highlighted. Ignore the configurable maps because that's new. In the sensors, you'll see there's now a selection of definable sensors and user definable, which is why they've been marked. The output functions, you'll now see that the basic PWM tables, there's two options, and there's 8 fan outputs where you can change the items to the on-off functions, and we'll go through that in a bit. And also the PWM where we can define our axis and stuff like that to make a custom map now. The map doesn't actually have to be used for a fan. You could use it to drive anything. If you wanted a 3D table for water injection, you could use this, and basically redefine the axis to whichever you want, say manifold pressure and RPM or manifold pressure and air charge temp. Change the frequency and then have a drive table, which is your actual PWM output. So I'm going to keep going up. The supercharger bypass valve is a new strategy that's been added. This is for a few new kits and cars that are going to be coming out, which we actually need this control. The idle control has got some changes to it for the derivative axis. So you can now have a derivative axis to the ignition timing and proportional and integral. Basically so that when you've got the engine RPM decelerating very fast, you can actually have an ignition change here to actually be able to catch it so that the RPM is not dipped as it comes back into idle, where a sudden change of ignition timing is pulling out when you've got a large error. There's now the driver demand selector. You can choose to have ALS based on PPS or TPS. And a few other functions which will be listed on the forum as well, but there's no point going over these now. So what we're going to do is first of all show you to a new feature in the Syvecs S Suite software. If you go to Cal, you'll now see there's a go-to option. The go-to is now basically an easy way to find calibrations that you require. So for example, if you want to find the closed loop lambda target table, you type in closed loop and you'll see then the lambda stuff comes up. So you then type in space loop lambda, and then you've got all of the lambda tables, so you can quickly then jump to say the base target table and it'll open up these for you. Again, I'm not sure if some people know, but you can actually set shortcuts to these favorite tables of yours by going to Cal and then go to edit shortcuts, and basically you can then set a table that you wish to use as basically based on an F2, F3, F4 function hotspot. So you can basically press, like say, F3 and it'll go to my ignition mount, F2 for the fuel, and likewise. Okay, so let's go over the new configurable items of the new 1.64 firmware. So it's worth resaving this now and actually changing this so that the firmware version is actually indeed 6.4, and just make sure there's no space at the end. Okay, so we've got that added. Now a new function of the new software is you can go to now view at the top here and customizing options. When you're in here, the configurable items that are going to be changed in the new firmware are all listed in here. So we're going to start actually from the bottom and work our way up. So when you go to IO configuration now, you've now got a section for car coding. Now some of our kits actually use these car coding features to be able to change items on the kits, but you can actually use these yourself to basically send out decimals or the number which you will require on a custom CAN to say a dash use. We actually use these though for just purely for kit use, and I don't see many reasons why the end user would really need to use these, but for our kits, the end users, they are important. For example, on the GTR, that we've renamed this now so that it's for TCM logging, and you can do TCM flashing and DCT clearing, all from the car coding, and it will obviously be renamed. So you could put in here TCM logging enable equals 1, and then abbreviation, say TCM log, and that way then the end user knows what this car coding function is used for. So it's really useful to help make the end user, the calibrator's life easier in understanding what a lot of these custom functions do when they're used as part of our kits. Okay, so then when we go to the configurable purpose maps. Now the configurable purpose maps are, or comp maps as some people call them, are extremely useful for adding more definition to some strategies. So what you've first got is you've got 10 2D configurable tables and then 10 3D configurable tables. So the 2D tables we first look at, what you can actually do is choose what you want the use to be. So say for example you would like to have a ignition timing adjustment, so we go to global ignition adder, and then when you're in here you can then go to the x-axis and basically choose what you'd like this adder to be based on. So you can choose the new configurable items, obviously the stuff that's labeled as U, but say if you wanted to have a configurable ignition and timing change that was based on, say, your relative fuel pressure, you could choose your relative fuel pressure there, then go where it says options, these maps have been changed, you need to proceed, or just tag them if you want to see which ones have changed. And then what you can do is you can go back into the view, customization options, configurable purpose tables, and find then that the 2D axis here, you can change the breakpoints for the relative fuel pressure and even change the dimensions, i.e. the amount of cells that you have in the map. And here then you could then change your ignition timing to reduce it or increase it based on ignition timing, based on the relative fuel pressure, sorry. And that's just a simple function. Other useful functions that are really useful for is if you go to view and then go to customize and options. When you're in here, you can then go to configurable purpose maps and then 3D. And then when you're in here, you can actually then say we could make a launch RPM adder. So we can go to launch RPM adder. And then in here, we could have the axis based on, say, manifold pressure and say TPS or PPS. TPS probably the most useful in this one. So then we go back to the normal view, so go view, customize and options. And when you're in here, you can go back to the configurable purpose tables, 3D, and now you'll see this launch RPM adder. Now we can then change the dimensions of the items, well, they're fine for the minute, and change the breakpoints to suit for the manifold pressure or the TPS. So if we were to set this, say, at 99, and then select all, and then go math interpolate X, and space them across, we're going to then proceed. And then what we can do is we can actually say, okay, well, if you're targeting, let's change the manifold pressure actually to make it a bit more easier to understand. If we change this to 1800, and then go SA, map interpolate again, and then go back. So what you can now do is if you wanted to, you could say, okay, well, I want to increase the launch RPM when I'm not actually achieving my launch manifold pressure target. So the easiest way to see that is if you actually then go back to launch control, look first at what the manifold pressure target is. So we're targeting 1700 millibar idle. So what we can then do is you'll then find that this new launch configurable map, comp map, is actually found then inside the launch control area, and you can see it here. So then what we could do is we can actually say, okay, well look, we'll increase the launch RPM 1000 RPM until it reaches its manifold pressure target, and then slowly ramp it in until it actually reaches that. Basically helping the turbo spool up quicker when you're on the line to have less lag. And you can do this based on only the 100% throttle. You can make it all the way down to here, and then if you wanted to, interpolate it that way. So that's one useful function of the configurable purpose maps. As we constantly improve our firmware versions of the ECU, we will find that more configurable purpose map options will become available. So presently you can see there's only a set amount that is available, but there is quite a good selection there. So you can change your fueling, your ignition timing, your torque estimation output, your gear blip amounts. You can limit the drive-by-wire. You can change your idle targets, your automatic trans duty that's going out. And the one that's worth talking over most now is that going over the basic PWM 1 through to 2, and then you've got the fan 3 to 8. Now these are part of the new firmware where it allows you in the output functions here to basically create your own custom maps for outputs on the ECU. So say for example you wanted to have a water injection control, for example, that was completely custom. I know we have a strategy for it already, but it's just basically on variables. If you wanted to have a 3D table which altered the duty to the solenoid based on say your air charge temperature and manifold pressure, you could then go to the output use and then name this as say water injection. And then abbreviations of your water, and say water injection. water inject, they all have to be joined as one word. It's important to remember that when it's the abbreviation. So press OK on that, and then select yes to say that they will have been updated. And then we can choose the axis to be, say, then based on charge temp, proceed, and say manifold pressure, proceed. And then once you've done that, go to view, customizing options, go to the output functions, and you'll see the new water injection solenoid here. So you can set a frequency for it, you can change your breakpoints for it, you can change the drive duty then. So if you want to, as the air charge temperature increases, you want to, for example, as the manifold pressure comes up, blend it in. So as your air charge temp comes up, you can hear, obviously the breakpoints for the manifold pressure at the moment are quite coarse, so we can obviously change those to make them more user friendly. And then obviously it makes a bit more sense, and you could then basically have this. So as your manifold pressure increases and your air charge temperature goes up, you can then increase the amount of solenoid duty, for example, to your water injection solenoid for a new custom map, and you then define that in the pin assignments to whichever output you wanted to wire that to. So once you've done that, what we're going back to with the comp tables then is if you go to view and customizing options, configurable purpose maps, you could then have a map that is actually a comp on top of that new map that you've created. So you could have a water injection duty adder that, for example, you wanted to have then based on if the inlet port pressure, or for example the pedal, if you wanted to have an adjustment based on pedal position, or any other manner of doing so. You could then basically do that, go to view, customizing options, configurable maps, and you could then obviously apply a comp on top of that if you wanted to. And you can obviously rename this as if you want as well into customizing options. And go to duty adder. And you can see that here it's water injection solenoid already labelled in here, so we know that what we're adding on top of. So it's really useful to be able to make some quite your own strategies now inside of the ECU for certain items. So one last thing to go over is the user definable sensors that are now available in the ECU. So with the user definable sensors, these 25 sensors are not used by any strategy for direct control. So these can be renamed to suit and then brought into one of the custom strategies that you wish to make under the output functions. So for example, you can see the list here of the user definable sensors. So if we were to say we want to change then oil level, we can redefine it to a new item that would be, say, based on let's say intercooler exit pressure. Now you can abbreviate it if you want, so you can just call it abbreviated to IEP, or if you want to, you can actually make it better than that by going int exit pressure, for example. So it's easier to understand when you're in SView because these will be pulled over. And then what you can do here is you can change the scaling on this type of sensor. You can change the units for it. You can change the decimal places, whether it's and just make it suit any actual application you need. Also, the make like here is really useful. So say if you know it's a pressure and you want to make it just like, say, engine oil pressure, you could then just select EOP1, which is engine oil pressure, and what it does then is it changes all the units, all the scaling, etc. To suit it. And you can then change your maximum values here and minimum values here in millibar to suit whatever you want, or change that into, say, PSI, kilopascals, etc. And once you've then done those, obviously you can then pull these user definable sensors into a custom map for a comp map, or if you want to pull them into a new map on here, you can then go int exit pressure and pull that in, so you can use it for a new custom map. So it's really useful and important for that. Now once you've made all the changes to the ECU and fixed everything how you'd like it in the custom comp maps and configurable outputs, all you need to do now is go to File and then Save, change the file name to know that you've actually upgraded the firmware, and I've just obviously updated it in the folder where it is at the present here at the top, but if you wanted to save it somewhere else you could just go Save To and then save it to your desktop, etc. After that then you would just then go to File, Close, Device Connect, and then when you're briefed with the options then to have load of the calibration or default calibration, you can then just load the file into the ECU and it should come online and say connected in the top right hand corner. If there are actually any problems when the calibration load in, say if something's not set correctly in the calibration, then the area down here which I'm highlighting will actually show you at the bottom what the calibration error is. And if you've got any problems with this, then just email the support at syvecs.com. But some of the key ones to remember is obviously make sure the pin assignments, there's no undefined items in there. Make sure in the custom CAN data stream settings that there's no items that are set as not set. And if they are set as not set, just make sure by looking at the previous calibration to set those as what they used to be. I hope this video has been useful, and the new strategies will make your powertrain control system run even better. Thank you.